Welcome back to Spring Into Math 8. Today's topic is scientific notation. Let's dive right in. So we may be wondering, what is scientific notation? Well guys, scientific notation can help you write really large numbers and really small numbers in a really simple, compact way that's easy to read and easy to understand. We're going to figure out how to do this, but for now, let's take a look at what it may look like. So at the bottom of the screen, we have 2.8 million listed here. Now that's a big number with lots of numbers at the end. So we can actually, when we use scientific notation, compact that big number to something like this, 2.8 times 10 to the 6th power. Now we're going to go further into this in a little bit. Okay, a basic definition. A number is expressed in scientific notation when it is in the form of n times 10 to the nth power, where the n has to be greater than 1 but less than the number 10, and that n always has to be an integer. Since scientific notation uses powers of 10, we need to be comfortable using them. If you need a reminder or refresher on powers of 10, please check out the previous lesson. So powers of 10 review. We have an example here listed. Do you notice the pattern here? 100,000 is equal to 10 to the 5th power. 10,000 is equal to 10 to the 4th power. 1,000 is equal to 10 to the 3rd power. Have you noticed that the exponent they have listed in each particular case tells you how many zeros are going to be on there? 5 zeros, 5th power. 4 zeros, 4th power. All right, positive powers. The power tells you how many decimal places to move, okay? The positive means we're going to move to the right, like we previously discussed. So we have 2.08 times 10 to the 4th. Now where that decimal place is right now, we need to move it 4 spaces to the right side because it is on the positive end. So 2.08 times 10 to the 4th finally comes out to 20,800. That positive 4 again tells you to move that many spaces to the right. So you can see we got a small number and made it large again. Negative powers. The negative power tells you how many spaces to move to the left. Okay, so you have, in this case, we use the same base number of 2.08 times 10 to the negative first power. So the negative 1 tells us to move the decimal just one place this time to the left because it's a negative number. So 2.08 times 10 to the negative first actually is equal to 0.208. Okay, so let's look at this example with instead of the negative 1 as an exponent, we'll use a negative 2 as an exponent. So that negative 2 tells us we need to move to the left not once, but 2 spaces. So 2.08 times 10 to the negative 2 is really actually equal to 0.0208. The negative 2 tells you to move those 2 decimal places to the left. Okay. That's it for today, guys. I hope you really enjoyed learning a little bit about scientific notation. See you next time.